Hey guys, welcome back for lesson 2.5. Let me present my screen and we'll go ahead and get started. Okay, so I keep mentioning proofs, and we're getting there. We're getting closer and closer. So I'm going to define a proof today. Okay, so let me get my pen. All right, where is my pen? Here it is. A proof is an argument that begins with known facts proceeds from there through a series of logical deductions and ends with the thing you were trying to prove. The thing you are trying to prove. Okay. All right. So writing reasons in a proof. Work with a partner. 4 steps of a proof are shown. Write the reasons for your statements. Okay. So we're going to continue to practice justifying, but now we're going to start using some of our geometry theorems and properties and postulates that we've talked about. Okay. So I'm going to erase that just so it's not so sloppy on the screen. Let me drag this down a little bit so we can see the entire proof. All right. So you're going to be given information. You're given that AC, the whole thing, is equal to AB plus BC. Okay. And you want to prove that AB is equal to BC. All right. And then we have this diagram. Okay. So the first statement is given. Okay. Then the second statement, we're going to think about algebra here. Think about how that, oh, is that it? Oh, no, that's not a typo. That is given. Think about algebra here. Think about our geometry postulates that we've learned about. You have to look at the diagram, erase that, and look at what's written and see if you can come up with the justification for it. Okay, so when I read the given, I think I read it wrong at first, guys. So let's go back a second. It says the whole thing AC is equal to AB plus AB. It did not say BC. I kind of assumed that. All right, so the second step says that AB plus BC is equal to the whole thing. That's what I read as a given. That's not what the given said, but that is step 2. Well, hopefully you're thinking that's what the segment addition postulate says, that this small segment plus this other segment equals the whole thing. And that is true. That's segment addition postulate. That's our justification. Segment addition postulate. Okay. Next, it says that AB plus AB is equal to AB plus BC. So typically what we do is we try to look to see if our 2 steps somehow gave us our third step, or is our third step separate? Did we come up with it from the diagram or somewhere else? So see if anything fits together here. You guys notice you have an AC here and you have an AC there, right? What is it called in math when you have something and you replace it with what it's equal to? You plug in the AB plus AB. That's called substitution. And I'll point it out again. Notice how if you substitute this AC with AB plus AB, you then get what's written down here. Or maybe I should say it a different way just so it matches up a little better. Let's do this. Okay, if you notice, you have AC and you have AC, right? If you replace this AC with what it's equal to, with AB plus BC, all right, you get what's written below. So that's substitution. And then from there, since you have AB on both sides of the equation, you can subtract it off and you're left with AB is equal to BC, right? If you subtract away AB from this side and subtract away an AB from that side, they cancel and you're left with AB is equal to BC. So that is subtraction. Okay, let's try another one. Now, proofs, like anything else, when you're not used to them, you've never done them before, they take time and practice. So don't get super stressed out right away if this isn't clicking. It does take some time and practice, okay? All right, so the first step in our proof is always the given. The given is written, the word is written, but what information was given is not written. So we're going to write that down. You're given that the measure of angle 1 is equal to the measure of angle 3. And we should mark that in our diagram if it isn't already. It is. Angle 1 has 1 arc on it, and angle 3 has 1 arc on it. So that's good. Then they said they used the angle addition postulate. So let's look at that. They said angle EBA. So this angle right here is made up by angles 2 and 3, which makes sense. Then they also said that angle, the next statement, angle oh, sorry, I'm not looking at the diagram for this one. So let's look at that red angle again, right? It says it's made up of 2 and 3, right? So what they did next is they looked at these two statements to come up with the third, okay? So what changed? We have EBA, we have angle 2, but instead of angle 3, we now have an angle 1. So what they did was they replaced this angle 3 with what it was equal to, and that was an angle 1. That's how they came up with this equation. So that's why they called it substitution, okay? Now we're going to use the commutative property, okay, which says if the measurement of angle it says measure of angle EAB is equal to the measurement of angle 1 plus the measurement of angle 2. Just flipping them around. Okay. We're going back down to the angle addition postulate. Angle 1 plus angle 2, those two angles, when added together, forms this big yellow angle. And you just have to name it. Okay, the name of that big yellow angle would be angle CBD or DBC, depending on how you name it. So it's the measure of angle CBD. And then finally, try to see if steps 4 and 5 can fit together. Look for what they might have in common. Do we see that they both have angle 1, angle 2 here, and angle 1 and angle 2 there? So using the transitive property, or this also could be called substitution, I would allow that as well. You're replacing angle 1 and 2 with what it's equal to, which is EBA. So now you have the measure of angle EBA instead of 1 plus 2 is equal to the measure of angle CBD. Okay. Let's move down. All right. We're going to skip over number 3. We're going to go to number 4. Now, this is a proof that we're going to do from scratch. We haven't done one from scratch before, so this will be the first. So when you do a proof, you're going to set it up, statements, and reasons. Just like the example before was a chart, right? We're going to make ourselves a T-chart. And every statement needs to be justified with a reason. And our reasons are going to be our definitions, our postulates, our properties, okay? So we're going to first give the given information, which says that B is the midpoint of AC, and also that C is the midpoint of BD. That is all given. All right, I'm going to switch colors just so it hopefully it doesn't look super sloppy. I'll do every other one. Now notice statement 2, I want reason 2 right next to it so it's easy to follow and read. Don't put statement 2 here and reason 2 up there. It makes it harder for the person to read and grade your proof, okay? We're trying to prove that AB, this little segment here, is equal to CD. But start with the given and see if that allows you to come up with any other information. If B is the midpoint, look at B. If B is the midpoint of AC, what does that allow you to conclude? If B is the middle of AC, hopefully that makes you conclude that AB is equal to BC. So we'll write that next. Okay, we're going to say that AB is equal to BC. And that's the definition of midpoint. Now, likewise, since we're going to use definition of midpoint again, I'm not going to make a number 3 because the justification is going to be the same. If C is the midpoint of BD, what does that allow you to conclude? That allows you to conclude that BC is congruent to CD, okay? So BC is equal to CD. And again, since that's definition of midpoint, I'm not making a new number. Okay, next one. Now look above and see if you can come up with a new statement. If AB is equal to BC and BC is also equal to CD, what does that allow you to conclude? Notice they kind of, you can almost like cross them out and you're left with AB is equal to CD. And we can call that either substitution or you can call that transitive. Okay. And you're done. That's what you're asked to prove, that AB is equal to CD. Right. Let's move down a little bit. All right, so there are some theorems here. It says properties of segment congruence and properties of angle congruence. So symmetric, transitive, reflexive, which we already talked about in terms of equality at the beginning. The properties basically look the same, but we're going to call it reflexive property of congruence, symmetric of congruence, transitive of congruence, just because we're using a congruency symbol and we're talking about either segments or angles. But reflexive would say AB is equal to AB. I always think about my reflection, right? When you look in the mirror, you see the same thing. So on both sides of the equation or congruency statement, you see the same thing. Symmetric, I think about flip-flopping. Two things are symmetrical on both sides. You can flip them around, looks the same. So AB is equal to CD, then CD is equal to AB, that's symmetric. Transitive, AB is equal to CD, CD is equal to EF, then AB is equal to EF. That's, I always look for where do they overlap, what do they have the same, you can kind of cancel them out, and what you're left with is AB is equal to EF, okay? And it looks the same for our angles. All right, so after that, we're going to, this just talks about our two-column proof that we already kind of worked through one example. Okay, it says in a proof, you're making one statement at a time until you reach the conclusion. Because you make statements based on facts, you're using deductive reasoning. Remember, that's why we studied deductive reasoning at the beginning of the chapter. Usually the first statement of and reason pair you give is the given information. All right, copy or draw diagrams and label given information to help develop proofs. Do not mark or label the information in the proof statement on the diagram. So over here, you have your statements based on facts that you know or on conclusions from deductive reasoning. Make sure you number your statements, and then you're going to number your reasons. Every proof is going to have a different number of statements. They're not all going to be 4-step proofs, okay? The reasons that we give must be definitions, postulates, proven theorems, all right? You can't just say because it looks like they're congruent or because it looks like it's the midpoint, okay? Oop, 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 oop. Not too far. All right, so we have another proof here to kind of work through. It's a fill in the blank type of proof to kind of just get us started again. So it says here, AB and DC bisect each other at point M, and BM is congruent to MC, okay? So I'm gonna mark that one statement that BM, let's mark it over here. Where's my, okay. BM, that segment, is congruent to MC. And then you're told again that AB, this one here, and CD bisect each other. So that word's important as well. That's going to allow us to make conclusions and mark up our diagram. All right, so you're given, they just wrote this piece of given. They didn't write the rest. I don't really know why. They should write it all. Maybe they'll write it later. Nope, they didn't. So you should write it all though. All right, next it says that CM is equal to DM. How did they know that? How did they know that CM and DM are equal to each other? It has to do with this given that they should have written. It says it because we're told that AB is the bisector. So that is definition of segment bisector. Okay. Then you're told that BM, the next thing, BM is equal to DM. Well, let's see if the statements above kind of fit together to give me that, because oftentimes that's what we like to do. We try to fit the pieces of the puzzle together. BM is congruent to CM. CM is congruent to DM. Oh, I see that CM is the end and the beginning, right? They overlap. I can replace the CM with something that's equal to. So that is transitive. Or you could call that substitution. I will take either. All right, the next statement. Now we've already used all these pieces, so I'm probably definitely going back to the diagram or the given. It says that BM, this piece here, is equal to DM. Is that what it says above? BM. Oh, they just went from congruency statement to an equality statement, because at the end, we're trying to get into inequality and equals. I'm not super picky about that. I don't make you guys do this statement. We're just going to say this is definition of congruent statement or segments. Okay, if segments are congruent, that means that they are equal. Okay, now, I don't know why my pen's being a little crazy right now with all these dots everywhere. Okay, now we want to look at the diagram and use segment addition postulate to come up with something. Okay, so being that, and this is sometimes hard to figure out where should I go from here. So sometimes it's good to look at what you're trying to prove. You're trying to prove something about segment AB, and I know nothing about segment AB yet. You also need to talk about AM, which I know nothing about AM. So maybe I look at AB, maybe I look at AM, and try to come up with some kind of segment addition. All right, well, what is AM plus MB equal? It equals AB. So let's introduce it in that way. AB is equal to AM plus MB. And that's a segment addition postulate. All All right, then from there, let's see. I don't know, but let me see if these puzzle pieces fit together to help me get this. Is there anything that kind of matches, that's the same? I see a MB and an MB. The letters are not the same order, but they're the same thing, right? BM and MB are the same thing. So could I replace this with DM? If I did that, AB, AM, and then this instead of MB would be a DM. And that is just by substitution. And you're done. Right? All right, I think we might have one more. Let me see. Let me see, guys. Hold on one sec. Yeah. All right. Where's my mouse? So I actually want to do, I think I want to do two proofs from scratch. No, I'll do these. Okay, let's go down to number 5. Write a 2-column proof. All right, so here it says that M is the midpoint of RT. Okay, so let's write that given, and then we'll mark up our diagram with what we know we're allowed to conclude. So 1 says that M is the midpoint of RT. That's given. All right, so then the second statement, try to use your given to come up with the next statement. Okay, think about what that means when you're told something's the midpoint. If M is the midpoint, that would mean that from R to M, this length here, is equal to T to M. So that's what we can write next. We can say that RM is equal to MT. And how do you know that? Definition of midpoint. Okay. So we used the given, we came up with this next statement. Let's look at what we're trying to prove to see where we should go next. We want to prove that MT, this little red segment, is equal to RS plus SM. Okay, MT was already introduced into the proof, but I know nothing about RS or ST. So let's try to introduce that into the proof somehow. What do you know about RS and ST? You don't know if they're equal because you weren't told that S is the midpoint, so you can't say that. But you do know that if you add RS plus SM, what is RS plus SM equal? It equals RM, right? If you add this little segment plus this little segment, it gives you the whole segment. And how do you know that? That's what segment addition postulate is. Segment addition postulate. Okay. Now see if you can fit the pieces together to come up with the next statement. This is kind of how you build. You start with the given, see what that allows you to say. Go to your diagram, get another piece. See if those puzzle pieces match up in some way. So I'm looking for anything that's the same, anything that overlaps, and I see an RM and I see an RM. So can I replace this RM with what it's equal to and write a new statement? And let's see what that statement might be. So I'm going to write RS plus SM is equal to, instead of RM, replace it with what it's equal to, MT. And that is substitution, or you could actually translate it again. All right, or I would take the transitive as well. Okay, so am I done? you want to prove that MT is equal to RS plus SM. If you wanted to use the symmetric property and flip it around so it matches, you could, but it's not necessary. Okay, and that's it, guys. All right, so I believe that's all I wanted to do today. It is. So I will stop presenting and I'll say goodbye and I'll see you guys for the last lesson of the chapter. Bye.